Hi, this is Alex from devstories.eu. GitLab CI/CD, Episode 2 of 14. You spend hours writing a perfect pipeline configuration file, commit it, and wait. But nothing happens. Your pipeline is completely useless without a computational engine waiting to pick up those instructions. This is where GitLab Runners and Executors come in. There's a common misconception that the GitLab application itself runs your build scripts. It does not. GitLab manages the repository and tracks the status of your pipelines, but it strictly delegates the actual execution. A GitLab runner is a separate application that operates as an agent. It continually pulls the GitLab instance, asking if there are any pending jobs it is authorized to handle. When it finds one, it pulls the job payload, executes the commands, and sends the logs and results back to GitLab. You have two main options for sourcing these agents. The easiest path is using GitLab-hosted runners. These are managed for you on GitLab SaaS and cover common environments like Linux, macOS, and Windows. Often, though, you need a custom setup. Maybe your build requires specialized hardware like a specific GPU or needs access to a private internal network. In that case, you use self-managed runners. You install the runner application on your own infrastructure. You can scope these self-managed runners broadly across an entire GitLab instance, share them across a group of related projects, or lock them down to a single specific project. Once a runner picks up a job, it needs to know exactly how and where to run the commands. This is defined by the executor. The executor dictates the specific execution environment for the job. Two of the most common types are the shell executor and the Docker executor. The shell executor is straightforward. It runs the job directly on the host machine's operating system using a standard terminal shell, like Bash or PowerShell. Because of this, all dependencies must be pre-installed on that host machine. The Docker executor operates differently. It spins up a fresh, isolated container for every single job, runs the scripts inside it, and tears it down afterward. This guarantees a completely clean environment every time. Let us walk through a concrete scenario by registering a self-managed project runner locally using a shell executor. First, you go into your specific project settings in GitLab and create a new runner. GitLab will generate a unique authentication token. Next, you install the GitLab Runner application on your local machine. From your local terminal, you run the register command. The prompt will ask for two main pieces of information. It needs the URL of your GitLab instance and the authentication token you just generated. This step securely links your local machine to that specific project. Finally, the setup will ask you to choose an executor. You type shell. From that moment on, whenever a job triggers in that GitLab project, your local machine will pull it and execute the commands directly in its local terminal environment. Here's the key insight. GitLab is the orchestrator, but the runner and its executor form the actual factory floor. By decoupling the management of jobs from the execution of jobs, you gain the flexibility to run pipelines on anything from a shared cloud container to a bare metal server in a locked basement. Thanks for listening. Happy coding, everyone.